So today for warm-up, we have the 1993 Calculus AB Section 1 exam, problems 8, 9, 10, 11 we'll cover here. We might do 12, we'll see. The first one says if y equals tan x minus cotan x, then dy dx. So all they're asking for is the derivative. All right, now what has to catch you right away is we should know off the top of our head the tangent, the derivative of tangent is secant squared, right? So I would just write y prime equals secant squared x. I'm going to stop right there. And when I'm doing multiplication, multiple choice, I can quickly say I'm not going to screw up these all in 5 seconds. I also know the derivative of cotangent, since it starts with a c, is negative. So a negative negative is a positive. I'm done. It is plus cosecant squared. No chain rule. The answer to the first one should be a 5-second problem. Yep. Next one, working our way down. If h is the function given by h of x equals f of g of x, where f of x is 3x squared minus 1 and g of x is the absolute value of x, then h of x is what? Well, you just have to plug it in, right? So you put the absolute value of x in, so you get 3 times absolute value of x quantity squared minus 1. And when you look, that answer is not there. Do you guys agree? Why is it not there?
It's squared. It's positive.
Yeah, it's going to be positive. Do we agree? So you can drop, you can think about it, absolute is going to be positive, but when you square it, it's going to be positive anyway, so it ends up being E. All right. If f of x equals x minus 1 quantity squared times sine x, then f prime of 0. Okay, got a product rule mixed with a chain rule. Do we agree? I'm going to call this f. I'm going to call this g. So f prime of x equals the derivative of that times sine x plus, and derivative of sine is cosine. I plug in 0. The great thing about sine of 0 is it is 0. The whole first term is going to 0 off because of that. So when I put f prime of 0 in, I get, and again, this is multiple choice, so my notation doesn't have to be that good. 0 plus negative 1 squared times cosine of 0, which is 1. So 1 squared times 1, the answer is D. Again, very fast problem. My argument here is we're going to get, it has to be in that 30-second range. 11. The acceleration of a particle moving along the x-axis at time t is given by a of t equals 6t minus 2. The velocity is 25 when t is 3, and the position is 10 when t is 1. Then you want the function. We know that the derivative of position is velocity, derivative of velocity is acceleration. So the antiderivative of acceleration is velocity. 6t squared over 2 minus 2t over 1 plus c. But we have an initial condition right here to plug in to figure out the c. So I know that 25 equals, and then do you guys agree that's 3t squared? So 3 times 3 squared minus 2 times 3 plus c. 27 minus 6 is 21. What's c got to be? 4. I used the initial condition to figure out the constant. Now, since it's multiple choice, I would do this first, and I would write this in, and then x sub t equals, all right, you guys agree that becomes 6t cubed over 2 times 3 if I just leave 6 halves, minus 2t squared over 1 times 2, plus 4t over 1, plus c. Oh, I did not have to work this hard, did I?
Another initial condition.
Yeah, but wait a minute. When we look at the board, can't be B. You just got sucked in by the distractor. because B, I think, is the velocity equation.
Oh, yeah.
It asks for the position. The only one that has 4t in it, the only one that has 4t in it is C. And I am not going to use the initial condition, because do I have to do that to get the answer? No. Got to look at this, and just because I can grind it out doesn't mean I should. All right. We're going to do this one together. These usually confuse us. All right. If f and g are continuous functions, and if f of x is greater than or equal to 0 for all real numbers, which of the following must be true? Okay? And it gives you 3 Roman numerals here. It says, if you integrate from a to b as the product of the two, all right, you can do it as the product of the integrals. Is that true? All right. Or if you have the separation of addition, we can do the sum of the integrals. Is that true? Yes. So 2 is true. And then the question is 3 true? You guys remember? And again, 3 can't possibly be true either. All right. The only thing we can do with integrals is 2. So the answer is, again, these are questions 7 through 12 on the 1993 AP Calc exam.